One factoring technique is called grouping. You need to use the grouping technique when you have 4 or more terms. However, we're going to be limited today to just having 4 terms. And so we're going to first try grouping the first 2 terms and then the last 2 terms. However, if that doesn't work, sometimes you have to rearrange. Then we want to factor out the GCF of each group. And then what you have factored out is if it matches exactly, then that becomes the GCF from both groups. And then we keep factoring if we need to. All right, so let's look at this first example. It says to factor the following, and we have 4 terms. 1, 2, 3, 4. So if I just looked and grouped these two and looked for a common factor, I don't see one. 3 and 10, H and K, M and N. Those two don't have a common factor either. So it's time to regroup. So how would you like to rewrite it? Perhaps you see that 10 and 2 are both divisible by 2 and they both have some H's. 3 and 15 kind of go together. So let's just rewrite this. And I would highly encourage that you do write it and then just go start from there. So let's group these two and these two. Please do not use parentheses because sometimes you're going to enclose the wrong signs. So let's look at this first group. What do these two terms have in common? Well, 10 and 2 and the H. So let's take out a 2H, and you want to divide each term by that because that's what factoring is. So we divide here, goes in there 5N, because 2 goes into 10 5 times, H goes into H1, and you'd have an N. Here we'd have a positive M. But let's keep going. Now let's look at the second group. First of all, notice that these are both negative. So we might want to take out a negative GCF of a 3, negative 3, and they both have a K. So let's take out a negative 3K. And you know when we're going to divide negative by negative, we're going to get positives. So that's going to be positive M. This is going to be positive 5N. Now, this is what you really want to make sure. Do those match? Exactly. Well, yeah, they do. They're just in the wrong order, but addition is commutative, so 5N plus M is the same as M plus 5N, so we can keep going. Right? So now, what I've highlighted in yellow, that becomes the GCF of both groups, and if I divide each group, what do you have left? You have 2H minus 3K. And that's your final answer. Now sometimes there's more than one way to rearrange it and get the same answer, and sometimes not. So let's look at the second problem. Some bigger numbers, but again, I would just group the first 2 and the last 2. So 42 and 6 are both divisible by 6. They both have some X's and some Z's. The question is do we want to take out a positive 6 or a negative? Sometimes if my leading term is negative, I like to take out a negative GCF. Sometimes that's helpful. So I'm going to take out a negative 6, and then I see an X squared and a Z squared. All right, so a negative divided by a negative leaves me positive 7Z. Right here I have a positive divided by a negative, so that's going to leave me negative 1. That's it, negative 1. So let's look at the second group. Well, again, my leading term is negative. 2 goes into 14, so I might take out a negative 2. They both have some X's and some Z's, so let's try negative 2xz cubed. All right, so negative and negative is positive. Well, that's positive 1. That goes in there negative 7x. No, 7z. Sorry about that. Let's see. Do those match? No, they do not. But they're awfully close. So what we can say about these two things is that no, they don't match, but those are opposites. Right? 1 minus 7z is the same as negative 1 times 7z minus 1. And again, you can verify that by multiplying it out and, of course, rearranging. and you should see that those are the same. So I can rewrite this using the opposite. Now what is that opposite going to do? It's going to change the sign. So I have negative 2xz cubed times negative 1 times 7z minus 1. This negative and that negative are going to become positive. Now I'm showing every step. You should be able to skip some of these steps. All right, so now, not done. Do those match exactly? Yes, they do. So that is a common factor. But what else do they have in common? Well, let's see. 6 and 2 are both divisible by 2. They both have some x's. They both have some z's. So let's see if we can find the greatest common factor out of each group. Let's see, we can take out a negative 2, an x, and a z squared, and a 7z minus 1. Wow, that's a lot. So if I divide all of this by negative 2, so negative 2 goes into 6 positive 3 times. X squared divided by x is x. The z squares would cancel, the 7z minus 1 would cancel. Now, let's look at this one. Again, we're dividing by here. So 2 divided by negative 2 is negative 1. X divided by x is 1. Z squared and z cubed would leave me a 1z, and the 7z minus 1 would cancel. Now usually we don't write that 1 there, but that would still be okay. Now let's say you didn't take out this whole GCF at one time. Let's say you just took out that 7z minus 1. Well, you would still have to look for the GCF, make sure everything is completely factored. But on this problem, I really want you to notice how way up here that did not match, so you had to use the fact that those were opposites to make them match. Let's look at this example. Well, we could leave it as is, but maybe you might see, hey, those 7 and 70 kind of looks like it should go together, and the 2 and 20. So let's just rearrange it. And then, since I've written the 7 and then the 70, small and then big, I think I'm going to write the 2, which is small, and then the 20, ignoring the negative signs, but just looking at the 2 and the 20. Sometimes it's a good way to arrange your grouping. All right, so let's look at this group and that group. All right, in this group, they're both divisible by 7, an x, and a y. So divide each of these by 7xy. This group looks like a 2, and since that 2 in front is positive, that's what I want to take out, a positive 2. You want to write that plus sign, very important. What else do they have in common? A y. So if I divide each of these by 2y, this is good, because once again, those match. And so what I've underlined in yellow becomes the GCF of everything. And if I divide by what I've underlined in yellow and write down what I have left, I have that answer. And you think, okay, that looks good, but it's not quite finished yet, because inside here there is another common factor of a y. So I want to take out that y and I want to pull it all the way in front just to make it look prettier. So I'm dividing each of those by y, and that's your final answer. So I would like for you, for class, to factor that problem and then tell me why this is not factored completely, meaning I should be able to factor it further, and how would I do that?